So we're going to continue on with our Algebra 2 review of logarithms, exponentials and logs, but in particular, we're going to be talking about logarithms in the first little section. This is still Algebra 2 review, and it's just preparing you for Chapter 5, which we're going to start on Monday. Chapter 5 is all about exponentials and logs. So we'll be learning how to take the derivatives, the antiderivatives, but also using those to perform the first derivative test, the concavity test, find the slope of a tangent line, and use that to write the equation of a tangent line. Pretty much all of the high points that we've studied so far, we'll do them again in Chapter 5, just with exponentials and logarithms. But today, it's Algebra 2 land for exponentials and logs. And in this first little section, we're going to go over some of the properties of logarithms that you'll use in Chapter 5. If you'll notice in example 1, I've given you actually several examples under that. Log base 5 of 5 cubed is 3. Log base 2 of 2 to the 6 is 6. Log base 8 of 8 to the x plus 3 is x plus 3. And then ln of e cubed is just 3. I mentioned to you guys that exponentials and logs are inverses of each other. So hopefully it's not surprising that you can use a logarithm to undo an exponential, and then an exponential to undo a logarithm, especially when you're solving an equation, which we'll talk about here in just a little bit. The first 3 examples, we can come up with a property. If you notice, for each of these examples, we have the same base on the logarithm as we do on the exponential. So log base 5 of 5 cubed, and see how this one's log base 2 of 2. If the bases are the same, the base on the log and the base on the exponential are the same, they cancel each other out and just leave you with the exponent. That's what the property says. So just a generic form of that property over here to the side, I would write log base a of a to the f of x is equal to f of x. So if you take a logarithm of an exponential and they have the same base, they're inverses of each other, so they cancel each other out. And then for the last one, ln of e to the 3rd power, hopefully that's not too surprising either, because we know natural log is just log base e, and so you're taking log base e of e to some power. So it really falls under the same property, but we will add a special property that just says ln of e to any power equals that power. So ln and e are inverses of each other. They cancel each other out. That's property number 2. Then property number 3 is illustrated down under example 2. You'll notice we have an exponential raised to a logarithm. But notice they have the same base. So if you have an exponential raised to a logarithm of the same base, then they cancel each other out once again because they're inverses and leave you with the function. So the property looks like this. A raised to the log base a of f of x just equals f of x. And I'm using f of x because it can really be any function. It's the a and the log base a that cancels each other out. And so then the last example on number 2, e to the ln of 4 equals 4. Can you help me write a property for that one? How would we write that in general? E to the
ln of f of x.
Good.
Equals f of x.
Good. Perfect. E to the ln of f of x equals f of x. So those are 4 properties you need to remember. They will be helpful in chapter 5. And then there are 3 properties here in the middle of the page that I've circled. Those are the properties that we're really going to focus in on today, expanding and condensing. So if you look at the first one, it says if you take log base A of a product, meaning 2 things being multiplied together, you can expand that to be log base A of x plus log base A of y. If you have log base A of a quotient, you can expand that to be a subtraction problem. You just take log base A of the numerator minus log base A of the denominator. And then finally, if you are taking the logarithm of a power, property number 5 says you can bring that power out to the front and multiply it. Now let's think about those properties for a minute. With these properties, multiplication implies addition, division implies subtraction, and raising to a power implies multiplication. Where have you heard those properties before? Not related to logarithms.
Exponents.
Yeah, exponent rules, right?
Yeah.
When you multiply same base of exponents, you add the exponents, or same base, you add the exponents. When you divide with the same base, you subtract the exponents, and then when you raise a power to another power, you multiply. That's actually not a coincidence because, again, exponentials and logarithms are inverses of each other, so they share some of the same properties. So if you know your exponent rules, these are pretty easy to remember, even though they look kind of messy. They're easy to remember if you remember your exponent rules. So that's called expanding. And then we could also go in the opposite direction and do something called condensing. So I can take an addition problem if I have 2 logarithms of the same base, and I can condense it into multiplication. Subtraction condenses into division. And then if I have multiplication, I can raise it up to the power on the x in this case. All right, so let's look at some examples at the bottom of the page. Number 1 says, well, each example says to write each expression as a sum and or difference of logarithms, and in parentheses I put expand. Because normally this is what the textbook asks you to do. Write each expression as a sum and or difference of logarithms. And so that's just a fancy way of saying expand using those properties. So for number 1, I have log base 3 of x over 9. Well, we said division implies subtraction. So I can rewrite this as log base 3 of x minus log base 3 of 9. That's actually not my answer because one of those logarithms will simplify. The second one, everybody knows what log base 3 of 9 is? It's just 2, right? Log base 3 of 9 is 2. So my answer is going to be log base 3 of x minus 2. Now, I will tell you that if this had been like log base 3 of 7, and that would give you a decimal answer, I just want you to leave it as log base 3 of 7. I don't want any decimals. Only simplify if it turns out to be an integer. Or a nice terminating decimal that you can write as a fraction. All right, number 2. Multiplication implies addition. So log base 2 of 5 plus log base 2 of y. And this one we're actually going to leave because log base 2 of 5 is a decimal. So we're just going to leave it in that form. Number 3, we have 2 operations we can expand. The first one is log base 7 of x plus log base 7 of y to the 5th. Remember, multiplication implies addition. And then we can take it one step further because we have an exponent. We can use property number 5 and pull that exponent down in front of the log base 7 of y. So our answer is going to look like log base 7 of x plus 5 log base 7 of y. Excuse me. Notice that I didn't pull down the 5 first because the only thing being raised to the 5th power is the y. Had the x and y been in parentheses, I would have pulled the exponent down first, and it would actually go in front of both logarithms in my final answer. So you have to pay attention to kind of how it's written. Number 4. Division implies subtraction again. So ln of e minus ln of x. Now that's expanded as far as I can go, but I can certainly simplify one step further. Natural log of e, that's one of my properties from the beginning. What's it equal to? Ln of e is equal to 1, because it's just going to be your exponent, and the exponent on e is just 1. So you're going to write it as 1 minus ln of x. Is this coming back to you at all? Properties of logarithms from Algebra 2? At least look familiar? Yes? Okay. All right, let's flip over to the back, and let's go in the opposite direction. Now we're going to condense. So we're going to take a larger expression, and we're going to use the properties in reverse. So the way the textbooks normally word it is to write each expression as a single logarithm. And in my words, we would call that condensing. So first thing I'm going to do on number 5 is I'm going to rewrite this as log base 3 of x squared minus log base 3 of z. Notice I moved my multiplication of 2 up to the exponent on x. I want to do that first because the only thing being multiplied by 2 is the log base 3 of x. Then I'm going to change my subtraction to division. When you go from subtraction to division, you'll go from 2 logarithms down to only 1 logarithm when you condense in that direction. So it's going to look like log base 3 of x squared over z. Also notice that the log base 3 is out in front. It's not part of the fraction. And again, there's only 1 log in your answer. When you condense, you go from 2 logarithms down to 1 if you're condensing subtraction to division or if you're condensing addition to multiplication. All right, number 6 is addition, and addition implies multiplication. So we have log base 2 of 1 over x times 1 over x squared. Again, we went from 2 logarithms down to 1. We multiplied the 1 over x times 1 over x squared, and we can simplify that a little bit to make it log base 2 of 1 over x cubed. That's one way that you could write it. What's another way you could write this?
X to the negative 3.
Yes, good. Log base 2 of x to the negative 3. That's another possibility. What's another possibility? What could we do with that negative 3? Pull it out to the front and just write it as negative 3 log base 2 of x. Any one of those 3 answers are acceptable, by the way. Just showing you all 3 ways for multiple choice purposes. Okay, but any one of those 3 would be acceptable. Any questions so far? Well, let's look at number 7. Number 7 is subtraction, which implies division. And so we have x squared plus 3x plus 2 over x plus 1. What's the base on that logarithm? Good, base 10. If it doesn't have a base, it's understood to be base 10. Now, for this one, I can simplify what's inside my parentheses by factoring. Yes?
Wouldn't the x plus 1 be squared?
Yeah.
Oh, shoot, I totally missed that. Yes, thank you, Nick. I appreciate that. It should be x plus 1 squared on the bottom, shouldn't it? Is everybody okay with me skipping that step and just writing it as x plus 1 squared? We'll want to skip it altogether. So we need to make sure that we do square it. But technically you would want to put the square on the x plus 1 first and then use the division. I just overlooked my 2 whenever I was performing my first step. All right, so I'm gonna factor my numerator. My numerator is gonna factor to be x plus 2 times x plus 1. And my denominator is gonna be x plus 1 squared still. And hopefully everybody can see that an x plus 1 is gonna divide out. So I divide out an x plus 1 on top, an x plus 1 on bottom, and that makes it x plus 1 to the first on the bottom. And that leaves me with log of x plus 2 over x plus 1. And that's pretty much as far as I can go. Alrighty, let's look at number 8. This one has multiple natural logs, so what you want to do is work from left to right. And so I'm going to do these two first. And I know, again, addition implies multiplication. So notice I'm working in pairs from left to right. Then I'm going to combine these two. Again, I have addition that implies multiplication. And then finally, my last two are subtraction, and I combine those to be division. And you can leave it in that form. Or you can distribute the 9x would be fine as well. But you don't have to. You can leave it in that form. Okay, any questions on expanding or condensing? Again, I just want to point out before we move on, anytime you condense addition or subtraction, you go from 2 logs down to 1. 2 logs down to 1. 2 logs down to 1 when you're condensing. All right, let's flip over to the next page. The next page is talking about solving exponentials and logarithms. And so there's a property at the top of the page that we could use. It doesn't actually, it doesn't work a lot of the time, but when it does work, it's extremely helpful. It says if log base A of m is equal to log base A of n, then m equals n. In other words, if I know log base 7 of x plus 2 equals log base 7 of 3, this property says what? X plus 2 equals 3, and see how much easier that makes it to solve? You just subtract 2 from both sides and you get x equals 1. So if that property applies, it's super helpful. It makes things super easy. But it only applies if you have a logarithm on both sides of the equal sign and you don't have anything else going on around that logarithm. That's the only time it works. Now, the steps for solving any exponential or log equation are as follows. The first thing you want to do is get the exponential or the log by itself. Then step 2, you're going to change forms. So if you remember in Wednesday's notes, when we did the frog on a log thing, to get from logarithm to exponential, from exponential back to logarithm. That's what I'm talking about for changing forms. Step 3 is to solve for x, and step 4 is probably the most important step. Check back into the original. I know in math class, you're almost always told to check your answer to be on the safe side and just make sure you're doing it correctly. This is not just to be on the safe side. This is actually a very important step because there are several times with logarithms where you come up with an extraneous answer. Do you know what an extraneous answer means?
It means like it doesn't work on a graph, like it's
Yeah, that's exactly right. It's not part of the domain. So, like, you work a problem beautifully, you do everything correct, and you come up with an actual answer, like x equals 2. and you wouldn't think anything about x equals 2 being a wrong answer, but when you try to substitute it back into the original, it's not part of the domain. It causes the function to be undefined. That's an extraneous answer. So unless you check your answers, you would never know whether you have extraneous solutions or not. So step 4 is extremely important with logarithms. Remember, you can't take the log of a negative number. You can't take the log of 0 either. It has to be positive. And remember, you can't have a negative base on a logarithm. The answer to a logarithm can be negative. You just can't have a negative base, and you can't take the log of a negative number. So that's really what you're looking for when you're checking extraneous solutions. All right, let's check it out. Number 1. My first 4 examples are log equations. Pretty obvious because they say log in the equation. Or they could say natural log, ln. But step 1 is to get the log by itself. And in this case, even though there's some things going on the left-hand side, the logarithm is by itself because 3 is the base on the logarithm, and 3x minus 1 is what we're taking the logarithm of. So technically, step 1 is done for you in example 1. The log is by itself. Everything on the left-hand side is part of that logarithm. So step 2 says change forms. Let's do frog on a log. So we're going to do 3 to the second power equals 3x minus 1. So 3 squared equals 3x minus 1. Well, that's just going to give us 9 equals 3x minus 1. Add 1 to both sides. Divide both sides by 3. And you get an answer of 10/3. Make sure that you check it. And when I say check it, you don't have to write anything down. All I'm wanting you to do is put 10/3 back into the original and make sure you're not taking the log of a negative number. That's all you're doing. So if you put 10/3 in for x, what's 3 times 10/3? 10. Excuse me, 10. And 10 minus 1 is just 9. So we're good. We're in the clear. As long as that doesn't give you a negative number there, that's all I mean by checking it. You don't have to write anything down. Most of the time you don't even have to type it in the calculator. You can kind of just do it in your head. That's what I mean by check your answer. All right, what about number 2? Is the logarithm by itself? Yes, it is. The x plus 6 is part of that logarithm. So we move on to step 2, which is to change forms. Change it to an exponential. What's the base on this logarithm? 10. So 10 to the first equals x plus 6. Well, that's pretty easy. X equals 4. Does 4 work back in the original? When we check it, sure does. When you put 4 in for x, 4 plus 6 is definitely a positive number. And that's really all you're checking for. Everybody okay so far? All right, number 3. There's a couple of different ways you could do number 3. I'm going to take advantage of the property from the beginning of the page since I have a logarithm on both sides of the equal sign. But before I can take advantage of that property, I actually need to condense both sides. By doing what? Yeah, I got to pull my exponents up. So log base 5 of x squared equals log base 5 of 4 cubed. Now the property states that you can drop the logarithms and set x squared equal to 4 cubed, which is 64. How do we solve for x? Square root of both sides, and anytime you take the square root of both sides, you must do the plus or minus. Okay, plus or minus 8 appears to be our answer at this point, but when we substitute those back into the original, which one's extraneous? The negative 8 is extraneous, because you can't take the log of a negative. And so, my answer is just x equals 8. say if -8 were my only option and it was extraneous, then I would just say no solution. But because I had an alternate solution, that became the answer. Okay, number 4, even though I have 2 logarithms, I can't really take advantage of the property that we used in number 3. So what are some other options? Condensing, good. So the first thing I'm going to do on 4 is write it as log base 3 of x plus 4 squared minus log base 3 of 9 equals 2. Now some of you can skip that step, and that's great. You don't have to write down every single step. Now we can go from subtraction to division and write log base 3 of x plus 4 squared over 9 equals 2. That was just step 1, getting the logarithm by itself. We had to do some work to get a logarithm by itself. That was step 1. Step 2 is to what? Change forms, doing frog on a log. So how would we rewrite this?
3 squared.
3 squared equals,
X plus 4 squared divided by 9.
good, 3 squared equals x plus 4 squared divided by 9. And so then I'm actually going to multiply both sides by 9 to clear my fraction. And I'll get 81 equals x plus 4. And my 9's will cancel, and my x plus 4 is still going to be squared. Or 9's divide out. Now what? Square root of both sides. And so I get plus or minus 9 on this side. I get x plus 4 on this side. And then I subtract 4 from both sides. So what is positive 9 minus 4?
Yeah,
5. And then, and then negative 9 minus 4? Negative 13. Are either of those answers extraneous?
Negative 13.
The negative 13 is. Now, my only answer is x equals 5. Let me make sure that you understand that not all negative numbers, or not all negative answers are extraneous. If you look at this original problem, had I come up with negative 1 for an answer, what happens when you put negative 1 in for x?
you get a positive 3.
Well, you still get a positive, don't you? So negative 1 would have actually been an okay answer. You have to make sure that when you sub it in, it causes a negative in the original problem. I just want to make sure that's clear. Don't always discount a negative answer. Make sure you actually sub it in and it causes a negative after the logarithm. Are we good so far? Yes? Okay, let's flip it over to the back. I want to go down to, well, we'll keep going. I might be beating a dead horse at this point, but let's keep going. No, it's just a smudge on the paper. So this number 5 should just be positive log of x plus log of x minus 21 equals 2. So again, we're going to condense the left-hand side. And when I condense it, guys, I'm going to go ahead and multiply them together to save me some writing, okay? I'm going to distribute x times x minus 21, and I get x squared minus 21x equals 2. Then I do frog on a log, change forms, and I get 10 squared equals x squared minus 21x. Any ideas on how to proceed from there? Well, let me ask you this. What kind of equation do I have? I have a quadratic equation, right? Now, from Algebra 2, you have at least 5 methods for solving a quadratic. You can do factoring, You can do taking square roots. This one you can't actually use taking square roots. Quadratic formula, completing the square, graphing. Quadratic formula always works, okay? But it's not always the fastest, easiest way. I like factoring for this problem. And if you're gonna solve by factoring, you're gonna have to get everything on the, well, I'm putting everything on the right-hand side. You just, as long as you put everything on one side, you're good to go. But don't use factoring unless you have everything on one side. That's important, okay? So don't just factor out an X here. Don't factor out the GCF. You have to have everything on one side before you begin factoring. So once I have everything on one side, now I'm ready to find two things that multiply to give me negative 100 that add to give me negative 21. What are those two numbers?
Positive 4, negative 25.
Positive 4, negative 25, okay, and then when I set each factor equal to 0 and solve, I get x equals negative 4 and x equals positive 25. Are either of those solutions extraneous? Just the negative 20, or just the negative 4. So x equals 25 is my answer. Alrighty, number 6. Condense the left-hand side again. So this time it's going to be division. 2x over x minus 3. Change it to an exponential. And you get 10 to the first power equals 2x over x minus 3. Then what?
Multiply by x minus 3.
Multiply by what?
X minus 3.
Yeah, multiply by x minus 3 on both sides. Clear your fraction, and you get 10x minus 30 equals 2x. Because you have to distribute the 10 to both the x and the negative 3. Then I get 8x equals positive 30, because I'm going to subtract 2x and add 30 in the same step. Everybody okay? Questions? So x equals what?
15 fourths.
15 fourths, okay. Is that extraneous?
Possibly.
2 times 15 fourths is okay, it's still positive. What about 15 fourths minus 3? It's going to be positive still, isn't it? So it's okay. All right, the last two examples are not logarithmic. What are they? Exponential. How do you know?
There's an exponent.
Because there's an exponent.
There's an x in it.
There's an x in the exponent. That's right. There has to be a variable in the exponent. So we're going to get the exponential by itself first by adding 1 to both sides. Notice that the x plus 5 is part of the exponential. So once you move the 1 out of the way, you now have the exponential by itself. Now we're ready to change forms. So if we change forms, what does this mean in log form? Log base what? What's the base? 3 of 4 equals x plus 5. Remember, the exponent is the answer to the logarithm, right? So log base 3 of 4 equals x plus 5. And you can always do your little frog on a log to check to make sure. Log base 3 of 4 equals x plus 5. Let's get out our calculators because that's going to be a decimal answer. And now I would prefer some decimal answers. Rounded how many places?
3.
3. And so I'm going to go to alpha window. I'm going to use my 84. If I use my 89, I'm going to have to do change of base formula and type in ln of 4 over ln of 3. Right? If you use the 84, you can type it in like this. Get a decimal answer and then do what? Subtract 5 from it. Do not round until your final answer. And so your final answer should be approximately negative 3.738. You do not need to check your answer for exponential functions because the domain of an exponential is all real numbers. So you shouldn't have any extraneous solutions on exponential equations, but only on logarithms.
How do you type it in the calculator again?
Alpha window, number 5. And that's on the 84. On the 89, it's ln of 4 divided by ln of 3. Change of base formula. Okay? All right, what should I do on number 8 first? What is it?
Multiply that 3 through 12.
Divide the 3.
Oh,
The reason is that 4 is being raised to the 2x, so we can't multiply them together.
okay.
But we do need to divide both sides by 3. And so we get 4 to the 2x equals 0.2 divided by 3 is 1/15. Make sure you don't use decimals until the very last step, okay? I changed mine to a fraction. So divide both sides by 3 and then change it to a logarithm. Log base 4 of 1/15 equals 2x. So in my calculator, I'm going to go alpha window number 5, log base 4 of 1/15. Get a decimal answer for that, and then just hit divided by 2, so it will use that entire decimal. And I get x is approximately negative 0.977 if I round to 3 decimal places. Okay, any questions on solving exponentials or logs? Let me just say one other thing about solving before I wrap up here. I have given you one method for solving exponentials and logs. It's also possible, instead of using the change forms, it's possible to use the inverse properties that we talked about on the first page. So another option for solving, like number 1, I'm going to write it in a different color over here. Another option would be to use the inverse property. So you have log base 3 of 3x minus 1 equals 2. And so you know the inverse is to have an exponential base 3. So we can use a technique called exponentiating both sides. And if you do that, you can write it as 3 to the log base 3 of 3x minus 1 equals 3 squared. So all I did is I used a base 3 on both sides, and as long as I do it to both sides, I'm in the clear. That technique is called exponentiating both sides. And when you exponentiate the left-hand side, see how it actually cancels out using that property from the first page? And you get 3x minus 1 equals 9. At this point, we're at the same place. Then you can just solve it for x. So, just giving you an alternative, if this makes more sense to you, you may use this method as well. Just whichever one makes the most sense. So that's exponentiating both sides. And then just to show you on the exponential